Module 7. High Availability Solutions. The high availability solutions available for SQL Server technology are built to help critical applications reduce the downtime of databases and also to prevent data loss by offering contingency methods. Let's take a look at some of them now. Failover clustering, logshipping, database mirroring, replication, and AlwaysOn. While some of these solutions help to protect the whole state of a SQL Server, such as failover clustering, others are more focused on protecting the data itself by distributing it across other SQL servers. Now, you might be asking how to choose from this list what is the best solution. The answer is always depend on the business priority. For certain companies, data loss is not a concern, as the SQL Server may host a read-only database, for example. But downtime is a problem, while the opposite is also true. The below table is known for establishing a baseline between each service level agreement and the downtime of the product according to each level. As you can notice, the more aggressive is the service level agreement, less downtime is available for the DBA to perform tasks such as patching or any other maintenance that require the software to be unavailable. If we consider the fifth row, this level is almost 100% of service level agreement. That means if SQL Server stays down for over 5 minutes during a whole year, the commitment will not be made with the contract. And these two concepts are also fundamental to understand how to pick up the right solution for each business. RTO means Recovery Time Objective, and it measures the amount of downtime a business can tolerate, while RPO, Recovery Point Objective, is concerned with data loss. The failover clustering requires at least 2 physical servers to take place. There are several configurations needed at both Windows and SQL Server level, such as setting up a domain controller and Active Directory, but those would not be covered here. Instead, I will provide a summary about how it works. Let's consider this scenario. One cluster node, or the primary Windows server, is located in New York, while the secondary is physically on Washington. There is a mechanism named isAlive that keeps checking each other to see if they are responding, just like a ping command. If one of the cluster nodes stop responding, and it's where SQL Server currently is, it will automatically fail over to the other. Consider that a physical problem happens in the primary server in New York. Immediately after this, the failover process takes place, and all resources, including SQL Server itself, the SQL agent, network IP, and others that may exist, are moved to Washington server. The logshipping is the easiest solution to implement and also the one with the lowest cost. This is because it has no special hardware requirements. If you have any version of SQL Server higher than the Express one, then you can configure and maintain the logshipping. It provides redundancy on each user database level. This is how it works. First, we have 2 servers, one defined as a primary and a secondary, and before configuring the logshipping for the desired user database, it must have a full backup at least. This full backup must be restored in the secondary server, and a log backup can be restored as well, but that's optional. Then, a job on SQL Server agent will perform the log backup and copy this file to a network share, that is a location where both servers have access to. Finally, another SQL Server agent job, but now on the secondary server, will perform a restore of this log backup file at a defined interval. The database in the secondary server will remain either in restoring or standby state until it is manually put back online. As you can observe, there are multiple phases until the log backup is replicated from one server to another, and factors like network latency, frequency of the log backups on primary, and frequency of the restore job in the secondary have a direct influence on this structure. That's why it's not a best solution if data loss is a concern. The database mirroring solution was introduced back in SQL Server 2005, and just like the logshipping, it provides protection on an individual user database level. However, instead of using log backups to replicate the data, it sends the transaction log records in real time, reducing the delays and allowing both servers' data to be almost or 100% equalized. There are 2 modes, the high performance and high safety, and it also allows an optional witness server to take place. In the database mirroring structure, when the primary server has any disruption, if it has mirroring configured, it will either manually or automatically fail over to the secondary server that will assume the role of primary. This is how it works in the high performance mode. First, there's a transaction happening in the primary server database. The transaction generates a log record, as we have seen back in Module 4 in the transaction log structure. The transaction is committed in the primary. After that, the transaction is sent to the mirror server. The log record arrives, and the mirror sends to the primary an acknowledged signal saying the transaction arrived with success. Only after that, the commit happens in the mirror server. So you can notice here there's a delay in the process to improve overall performance. Remember that in a production server, hundreds or even thousands of transactions can happen at the same time. Let's check now the events, but for the high safety mode that prioritize data synchronization, but require more performance to take place. So here is our first transaction again. Log record is generated. Now the transaction data is transmitted before the commit in the primary server. The log record arrives in the mirror. The acknowledge is sent back to the primary, and only after that the same transaction is committed almost at the same time in both servers. This is known as a dual commit. It's a more efficient way to ensure data synchronization. So if your business prioritizes data loss, if data loss is a concern, then the high safety mode for the database mirroring is recommended over the high performance. The replication solution is different from we have seen in the logshipping and database mirroring, because it focuses on replicating specific tables from a database instead of transmitting the whole transaction data or restoring log backups. This is the more complex to maintain than the others, as it deals with logical structure as well. There are three modes: the snapshot, merge, and transactional. We're not going to cover them as they are out of the scope of the course, so instead provide a brief overview on how the replication works in some cases. Consider a company with a headquarters located in New York and some other offices in Texas, Arizona, and Florida. Each office has a local salesman who goes out in the field selling agricultural products on locations where there is no internet signal for whatever reason. He only uses a tablet to display and sell product to customers. There's a main database hosted in a server in New York location that contains the inventory of all available products and the current amount in stock. Once a new product has arrived, the main inventory database is updated, and this data is automatically replicated across the other offices, so the salesmen are able to show an updated product catalog to their customers. And after the local sales take place, each office has to update the local databases, then the data is sent back to the main inventory site. The AlwaysOn was introduced in SQL Server 2012, and it uses the same model of the database mirroring to transmit data, but instead it can do this for a group of databases called the availability group, which can contain up to 10 user databases. While it requires Windows Server Failover cluster installed, the SQL Server's primary and secondary can be standalone copies, and they do not need to share the same disks, just as a normal failover cluster structure. Here's a graphical representation. We have three servers, where in the AlwaysOn terminology we call them availability replicas. One is the primary replica, one the secondary, and a third serve as a disaster recovery environment. On this scheme we have two availability groups: financial, that has databases credit, report, and cash, and funds, containing databases client, invest, and fund. Now suppose a critical failure happens in the primary replica. The availability group has to fail over to the secondary, and this will happen automatically or manual, as it depends on how the data synchronization was set up. For a synchronous data commit, the failover only happens when it's done manually with the allowed data loss option verified. This is because this option is more recommended when the replica is at a great distance, physical distance from the primary, just like a disaster recovery server, and data loss is not a primary concern. The synchronous commit provides full synchronization between the replicas, and there is no data loss, as the transactions are dual committed before they are considered complete by SQL Server. In the next demo, I will be demonstrating the configuration for the Logshipping and AlwaysOn. In this demo, I will show you how easy it is to configure and maintain a log shipping structure. The scenario for this exercise is the following. We have two different Windows servers, Node 1 and Node 2. Each one of those have a different SQL Server, a standalone copy. This one is Kratos. This will be our primary SQL Server instance for the log shipping. And on Node 2 we have Samus, which will be our secondary. So to start, I'm going to go here on primary and I'm going to create the Joker database, which is the one we are going to use for this exercise, and I'm going to perform a backup of it to the SQL Share folder, which is a network share between the two servers, so the two servers, they can actually see the same folder. Let me run the script. Okay, now I'm going to go to the secondary and I'm going to restore the full backup. Before that, let me copy the file to the desktop. There it is, the Joker full.back. And I'm going to restore using the no recovery option, so the database is open to receive transaction log files. Let me hit execute. Command was okay. I'm going to refresh, and here we have the Joker database in restoring state. So now it's time to go back to the primary server and start the log shipping configuration. Let me disconnect this, and I'm going to refresh. There is the Joker database. Right click, properties, and I'm going to transaction log shipping option, and I'm going to mark the option enable this as a primary database in the log shipping configuration. The first option to change are the backup settings, and here I'm going to put the shared folder address, SQL share, that's it. And these are the threshold for file retention. So delete files older than 72 hours, this is by default. I'm not going to change this, neither the alert option to alert me if no log backup occurs within 1 hour. What I'm going to change here, it's the job schedule for the log backup in the primary. I'm going to make it run every 3 minutes instead of 15, and I'm going to hit OK. Now it's time to add secondary server, which will be Samus, just like that. Okay. The first tab is to initialize the secondary database. Since we did the restore in the database, it's already in restoring mode. We have the option here, no, the secondary database is initialized. So I'm gonna go to the next tab and the copy files destination. This should be a destination usually in the secondary server, which is in my case, so C user. I'm going to put it on desktop. I'm not going to change the delete copied files option, and I want this job, the copy one, to run every 1 minute. The last tab is to restore transaction log. So SQL Server gave us two options here: to restore the database in no recovery mode, so it will be in restoring state, not available to users, or in standby mode, where users are still able to read data. And I can mark this option to disconnect them when the restores are in process. These two options are for delaying the restores, by default it's no delays, and alert if no restore occurs in determined period, by default it's 45 minutes. I'm gonna leave like this. And the job name will be this, and I'll change the schedule so the restore will take place every 5 minutes. I'm gonna hit OK, OK again, script configuration to new query window. I just wanted to show you this because it's the reason I'm doing in the interface. So it's more easy to learn step by step going through the graphical interface other than that whole piece of code. I'm gonna hit OK. What's going to happen now, the jobs have just been created. Let's see under primary, so we have the alert job to alert me whenever the log backups are not occurring in the primary, and the log backup 1. On the secondary, if I expand the job activity monitor, there are 3 jobs: the alert to alert me if no restore occurs in determined period, the copy job that will run every minute, and the restore one. I'm going to pause the video now and go back a few minutes later to show you the results of the log shipping configuration. So here are the results for the jobs after some minutes of execution, and let's take a look now at the outputs for both copy and restore jobs on the secondary server Samos. I'm going to right click here and view history. These are the output for the copy job, and from the restore ones you can see both were successful. And since the font here is very tiny, it must be difficult for you to read, so I separated the timeline of the events in a notepad here so you can actually read the output from the jobs. So here are the copy job steps. Here's what SQL Server does. It retrieves the copy settings, primary database, primary server name, picks up the backup source directory and destination. Here's the last copied file and the messages that says the copy was successful. And it also checks if previous copied log files are required. So it checks if nothing is missing to make sure the synchronization is okay between the primary and secondary. And this is the timeline for the restore job. Starting the transaction log restore, retrieve the settings. This is the file that picked it up on this specific job. I collected the output, and then it marks the restore operation as successful, and it says number of log backup file restore is 1. Now, one thing that's tricky during the troubleshooting of log shipping is sometimes there are no files to be copied or there are no files to be restored, depending on the time frame you configure as the interval for the routine to happen, for the copy job, for the restore to happen, or even for the log backup in the primary server. But even so, SQL Server agent will tell the job succeeded. So when troubleshooting log shipping, you need to make sure you look output by expanding each of the entries here, so you can actually see if there was a file restore, or sometimes it says number of file restored or number of files copied equal to 0. So sometimes your log shipping structure may not be working at all, but you still see the job succeeding. That's a false alarm. Okay, let me close this here, close again. These are all the log backups that are processing from the shared folder to my desktop. This is the secondary server, and refreshing the database. There's the Joker database in standby read-only status. And also there's an interesting report. If we right click here in transaction log shipping status, it's a graphical report where we can actually see the latency of the files that are being transferred, the time since the last restore, and the SQL Server tells us a status, if it's good or alert. If anything was wrong, it would be written in red here, and it would be like status alert. So the time since the last copy, the restore settings, latency of last file is 2 minutes, the threshold for the alert, we configure the alert if it's enabled or not. And if we go to the primary server, right click and run the same report, transaction log shipping, it will have almost the same information, but now for the primary standpoint. Let us take a look here what it gives us. This alert here was for a previous database Batman that I created some time ago, but I have deleted, so it's not relevant for this exercise, but it's just to demonstrate to you what happens when a log shipping is out of synchronization. And the Joker one is good, and here it showed me the last backup file that was restored, that was processed, correcting. So it says if the alert's enabled for the backup, the threshold for the alert, and time since my last backup. Now, before I finish the exercise, I want to show some considerations for the log shipping. I'm going to write here on the screen. So when troubleshooting log shipping, we need to make sure, especially in production servers, that things change. This was just a simple example on small databases. So things to consider are the frequency of the log backups in the primary server, the frequency of the copy log file job, the frequency of the restore on secondary, and also the database size where we are configuring log shipping, network latency, transaction log activity. Why? Because during huge database loads or maintenances such as rebuild indexes or bulk loads or whatever transactions are done by the application that causes the log to grow very fast, larger will be the log backups during this period. So it may impact the log shipping synchronization. So when configuring log shipping in production environments, you need to make sure that you agree with your client what are the required times for the service level agreements. Otherwise, you could not meet their expectations. So log shipping is considered a cheap solution because it requires no special environment like clustering or shared disks, no additional features to be installed. It's basically a backup and restore process. So you need to make sure you consider these factors when configuring and maintaining log shipping in a production server. Now the last step of the exercise, I'm going to create a backup job, a log backup job in this case, to run in a very frequent fashion in an order that it will interfere in my log shipping structure. So here's a job. It's going to perform a log backup of Joker database to a different location, and it's going to run every 4 minutes. So this way my log shipping structure will be broken very shortly, and I'll be able to show you what error is received on the destination server, the secondary one. I'm going to pause the video now and return a few minutes later so you can actually see the errors in the output for each job. So this is what happened after a couple of minutes. The restore job has failed, and let me take a look at the output here. Expand. These are the errors. Again, I'm going to show you a notepad for a better view. This is what happens. SQL Server throws an error saying it could not find a log backup file to be applied to the secondary database, and the log backup file begins at set number this, which is too recent to apply to the database, and the restore log operation terminated. So what happened is the log change sequence was broken because there's more than one job performing log backups. So the log shipping synchronization would mess it up. And if you see this case in production, you probably have to do two things. The first one is to actually verify why there's a second job performing log backups when you have log shipping in place. So you either need to remove that job or disable it, and then you are going to have to configure the log shipping structure again, because once the log chain is broken, the only way to restore this is by restarting the log shipping sequence and by taking another full backup so the sequence is reset. This is the demo for the AlwaysOn availability groups solution. We're going to use the same structure I used it in the log shipping demo. Here we have our node 1 with Kratos SQL Server, and on the secondary node we have Samus SQL Server. They will both be part of our structure. I just wanted to show before I start a picture of the cluster we have. Both node 1 and node 2, they have no resources on it. This is where the availability group that I create is going to show up a few minutes from now. Let me expand the Kratos SQL Server, which is the primary availability replica. We have 4 databases: Captain America, Hulk, Iron Man, and Thor. They're going to be part of the availability group that I'm going to create next. Right click here, new availability group wizard. Let me expand. I'm going to call it Avengers. Next, I'm going to select the 4 databases to put on it. And now it's time to add the secondary replica. As you can see, Kratos is already selected as the primary one, and I'm going to add SAMUS as the secondary. There we go. Now some important configurations regarding data synchronization. You can see down here, for both Kratos and SAMUS replicas, the data synchronization mode is asynchronous commit, and that means the replica will use a synchronous commit as it is written down here and support only the failover with possible data loss, manual failover with possible data loss for both replicas. So let's imagine the following scenario. The availability group is currently active on Kratos SQL Server, so it has the primary role on SQL Server Kratos. And if Kratos has a problem where the SQL Server crashes or needs to shut down, the 4 databases we just added, they're not going to move automatically to SAMUS. The SQL Server will need a DBA to enter the SQL Server SAMUS, issue a command saying, I want the databases to be failover, I want the availability group to be failed over with possible data loss, forcing a failover, acknowledging that a data loss is possible. So this kind of configuration is usually recommended for disaster recovery scenarios, usually for servers with a great physical distance one from another. Okay, and if we click on synchronous commit, we can select support only manual failover, as it's written down here, or both automatically and manual failover. This configuration is more recommended for production servers where data loss is a concern, because the data will be almost equalized or 100% equalized between the replicas, while in the synchronous mode probably you have a data loss because performance is more optimal, but data is not 100% equalized with both replicas. I'm going to leave in the asynchronous commit mode just so we can see the differences, and later I'm going to change this. But for now, I'm going to leave it like this without any option selected. The endpoints are used to receive connections from all the SQL servers, but they're not going to be changes for this demo. And the backup preferences is just a matter of preference for where the backups will occur based on which role the current replica has at the moment. I'm going to select any replica, because this is not a concern for the exercise. In the listener, they allow a DBA to configure a name for the client to access the SQL Server instance, no matter on which replica it is currently running. Also, I'm not going to configure this for the exercise, so I'm going to hit next. Here's a standard warning about the endpoints. Yes, I'm going to proceed. Now, data synchronization preference. This is the initial data synchronization preference. I can do it manually by selecting join only or skip it. All I need to do is transfer the backup file to the secondary replica and restore the database there, just as we did with the Logshipping. But instead, I'm going to put full, and SQL Server will use the network share to perform backups and log backups and the restores. So it's going to save me a little time. I'm going to hit next. And now the validation takes place. Everything looks good so far, only a warning. Next. Here's a summary on the actions I just selected, and finish. SQL Server now provides me a dashboard on each task that it's going on. As you can see, it's restoring the database on the SAMUS SQL Server and joining to the availability group Avengers. It should only take a couple more seconds before it joins the last database. There it is. Now if I expand the availability group AlwaysOn tab, let me refresh on Kratos. There it is. Here is the Avengers. You can see it has the role of primary because I am on Kratos SQL Server. Availability databases, here they are, Captain America, Hulk, Iron Man, and Thor. And if I refresh the database status, they are synchronized. If I go to SAMUS, oops, there it is. I'll also be able to see database, but they are synchronizing. because I selected the asynchronous commit mode. If I selected synchronous commit mode, they would be synchronized instead of synchronizing. I know it sounds a little bit confusing at first, but it's easy to understand when you get the big picture. If I open the availability groups, you can see the Avengers. It has the secondary role on Samus, which is the intended, as we just configured. And here is the cluster I showed earlier. Now you can see the Avengers availability group it is running actually in the node 1. You can notice it's not a whole SQL Server that is allocated to one node or another, only the availability group. This is how it works in the AlwaysOn, which is different from the standard failover clustering. Let me expand a new query now on the secondary replica Samus. I'm going to run a select name and state description from the sys databases. There we go. You can see it mentions all the databases are online that are part of the Avengers structure. But if I try to use one of them, like use Iron Man, it's going to throw me an error saying the database is participating in the availability group but not accessible for queries. Data movement it's either suspended or the availability replica is not enabled for read access. This is intentional because I did not enable read access, read-only access during the configuration, and it tells me what it needs to be done here. If I go to the primary, right click on the Avengers and properties, I can change this option right here. I can put read intent only or yes for both replicas, but for now I'm going to leave it just like this. Next, I wanted to show you a couple of commands we can enter to pick up information from the availability groups that are also stored in the MSDB system database, such as this one, get replica name, status, and synchronization description. There it is. Both nodes are connected, synchronization it's okay. Databases per availability group, per replica, failover type, and synchronization health. There it is. Each database, the replicas. There are some performance counters related to the AlwaysOn structure too. We're going to see more about performance counter in the next module, performance. And using these performance counters, we can monitor some bytes that have been sent to each replica. Again, it's just a sample on how much level of information we can retrieve using Transact SQL inspecting these tables. There are much others, these are just some samples. Let me close down this and this. Now I'm going to simulate a crash in the primary server, Kratos. And before that, let me close this. Before that, I'm going to recycle the error log on Samus so we can actually see the errors. There it is. After I performed the failover. So going back to Kratos, I'm going to put a shutdown with no wait. SQL Server is terminated. If I refresh it here, it's going to throw me some errors. Not responding. Let's wait a couple of seconds. Okay, so my screen got stuck here. I'm going to pause the video and return a few moments later after it has finished the shutdown so you can actually see what's going on with the availability group databases. And here's the error. Okay, that is expected. If I go to Samus and expand the databases or the availability group, refresh, it's in the status resolving. So the databases are not available. You can see by this red icon besides them. If I try to read the error log to understand what happened, let's take a look. There is my error log. If I scroll down a little bit, There it is. Let me switch to text mode. It's easier to grab the messages. Okay, there it is. The local replica of availability group Avengers is going offline because the corresponding resource in the Windows Server clustering is no longer online. That is the SQL Server Kratos. This is an informational message, and here the state of the local availability replica changed from secondary normal to resolving normal. So the databases are not going to be started, the whole availability group is not going to be started until I manually failover stating that I allow the data loss to happen. If I do this, again, select the status of the system databases, they are still showing online, but when I try to open them, I'm going to receive the very same error. Let's use Thor, go. Same scenario. What I'm going to do now is force the failover of the Avengers availability group, allowing the data loss to happen. And before that, let me recycle the error log again so you can see the errors without flooding the screen from messages. There we go. I'm running this command on the SQL Server that I want the availability group Avenger to move to. In this case, I want them to move to Samus. There it is, execute, and completed without any errors. If I refresh the screen, let me collapse this, refresh, availability group, there it is. Now the Avengers is showing as primary on the Samus SQL Server. So my secondary replica assumed the availability group Avengers with the role of primary. If I try to read the error log now, I'm going to see what's going on. Again, to text mode. There it is. The database is changing from resolving to primary because it was pending the manual failover confirmation due to a role synchronization. Message is written here. Primary pending to primary normal. I go back to my cluster interface, hit node 2, there it is, the Avengers. Just like that. Now I'm going to show you the difference with using synchronous commit with automatic failover. First, let me open Kratos, and I'm going to drop the Avengers availability group. Okay. Drop availability group Avengers. There we go. I'm going to remove the databases from the secondary. They remain in a restoring state. Otherwise, I'm going to have errors when recreating this structure. There we go. Last one. Alright. Moving back to Kratos. Using the same procedure as before. Avengers. The 4 databases. Adding the replica, Samus. And now I'm going to select synchronous commit for both with automatically failover. There it is. And no changes to the other options, just that one. As soon as it completes, I'm going to shut down the primary replica Kratos so we can see what happens with the secondary right away. And we can see the difference between the asynchronous commit mode. Should only take a couple more seconds for Thor database to join the availability group here. Last item. Just a couple more seconds. There we go. Close it. Expanding again. Primary Avengers on Kratos. That's okay. And if I refresh here, everything is synchronized. It's the expected way. And secondary on Samus. Let me close this out. Closing this too. And now I'm going to shut down Kratos immediately. See what happens next. If I refresh this, it's already a primary. As you can see, there is no need for DBA intervention after the primary replica suffered a crash. For production environments, this is the more safe options where you can configure your availability groups unless data loss is not a concern. You were able to see how quickly it was compared to the other method using asynchronous commit. If we use the error log now on the secondary, you can see that it takes only a couple of seconds before the databases are brought back online. Let me switch to text mode again. There we go. See, right here, the connection terminated with primary, changing to resolving, and then primary normal. If I expand the dashboard, it's going to give me a good status for Samus, and of course the other one is down, so possible data loss alert.